you're having like a tough time with any part of the assignment, like we have Alicia and I hold office hours on Friday, like ahead of like the due date on Sunday, so you don't have to stress if you come in on Sunday and realize it's too much to do. But without further time, we will dive into databases today. All right, so last week kind of went over this. Went over the server-client model, so how you can communicate with your from your computer with servers via requests and responses. Went over request methods, routes, URL parameters, and response bodies and codes. And the assignment, just another thing, we put out weekly surveys with each assignment due on Sunday, so these are actually mandatory, and please do them. You get a lot of useful feedback and information from them for us to make the course better for you. So also, the median and average time spent on last assignment was 4 hours. We like this to be closer to like 2 or 3-ish, so we're going to try to make the assignment slightly smaller for the passing grade, and then add more challenges and extensions for people who want to dive deeper into backend stuff. And grades for the first assignment will be released on Friday. All right, so let's talk a little bit about data persistence. So this is basically how we were storing data. On the last assignment, we had this one Python dictionary and just a bunch of key value pairs and storing all this data just in the dictionary. And we had an ID counter to make sure that we're incrementing our IDs so that they stay unique. So this is jank. It's not great. We're going to change it. So some deficiencies right now, if you stop running the server, you lose all the data that you added except for whatever you hard-coded in the beginning of your file. So that's not great. When we have an application and say a server crashes or it goes down, loses power, we want all the data that we had stored previously like still available and still okay. So also this does not scale efficiently. Python dictionaries aren't great for holding very, 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 very large data sets that we would want to if we had any like meaningful like scaled application. So that's also not great for scaling. Also, there's minimal format enforcement. I know in the logic we wrote for our routes, we were trying to like have the logic so we only insert posts in a specific format, but really there's like if someone really wanted to, they could try to find a way to hack around or like stop, like you could put some data in the dictionary that's not the same format as all the posts that are already there. And also like not protecting yourself from it. So like say you write one code one day that doesn't actually format the data correctly when you're putting it in the dictionary, and then you have a bunch of people hitting your server and creating all this data that's in the wrong format, then suddenly you have like this massive data structure that's now not consistent anymore, and that's not great. So part of it's protecting the data from outside people, and part of it's also protecting it from ourselves because developers make mistakes too sometimes. And then also, like as I mentioned before, that dictionary setup just doesn't feel right. It's kind of jank, it's not great, and there are many solutions out there to fix it. The one we'll talk about today are databases. Databases are a really great tool. The fundamentals of any database is that it's just a bunch of information that's organized in a very clean way that's easier for us to understand and manipulate with. So it's easy to access, update, and manage this data, run statistical analyses on it, or pick apart different pieces that you care about, or update and create new things. And we implement any database as a collection of tables. So go into what a table actually looks like. So here's an example of a table. As you can see, so we have a table of a bunch of fruits up here. So going through how to look at this table, so columns basically represent a specific field that you care to store. So in the case of this table, we want to store an ID along with a name, which is of type string. We want to store a quantity of type integer and a price, which is a float. So the columns represent different categories of information we care to store, and rows represent an instance of this collection of information. So in the first row, an apple. So an apple, its name is Apple. It has an ID of 1. We have 10 of them, and the price is $1.15. So in any case, the columns just represent the pieces of information you care to store, and a row is an instance of a collection of that information. So going through also, columns enforce the same type restrictions on whatever data is in that column. So in the case of name, they're all strings. It would be weird if some were strings, some were ints, and some were booleans. That would be kind of weird. So columns naturally enforce that the same data is of the same type, and gives us that format structure that we're looking for. So let's go through some examples also talk about IDs. So IDs are unique identifiers, and we want to have a way to uniquely reference every single item in a table. They're required also for every item in a single table, and they're specific to that table. So if we had multiple tables, as we'll show later, the IDs are only specific for that particular table. So having IDs be globally unique is very useful. An example of like a route we did last assignment where you want to access a particular user. Two users may have the same name, like John Smith, but no two users will have the same ID. So this makes it really easy for us to specifically find a single piece of information if we're looking for it. So say we want to add, oh geez, that got next. Oh, that's strange. All right, cool. Sorry about that. All right, so another thing. So we added this new thing, new item, pair. So IDs auto. Is this the old? Wait, are these the old slides? I changed a little bit before.
Oh, you did?
Yeah.
Should I pull those up?
Yeah.
Oh,
so sorry, 1 second.
Space.
Oh, do you have to get a new link for that?
Do I?
I don't know.
No, I don't think so.
No,
it's still in here.
All right. Oh shit, I added some transitions up better. Yeah. Okay, we're good. All right, cool. So another thing is that IDs automatically increment. So you can see when we added this new row here for pair, the ID is automatically 4 for us. So this helps us ensure that IDs are always unique by not repeating them, and it's handled for us in most database systems to automatically increment the IDs as we add new items to our database. So yeah. So say in the case that we want to actually remove one of our items, say we're getting rid of our bananas, what happens when we create another row in the table? So when we add a new row, say peaches, this idea of peach is now going to be 5. It's not going to be 3 because when we remove items, we don't reuse those old IDs. This is very important because not only would it be kind of difficult to keep track of what IDs have been deleted, and so like that we can like hack a way around to reuse them, but it's much cleaner and easier for IDs to be unique within the table and also across time also. So there's time and variance. Cool. Another key distinction is a database is not just a single table. A database is many tables, or it can be. It can be one, but it can be multiple, and they're different. So say we have a database that we want to store fruits. Say we're a grocery store, but we also want to store a table representing all of our employees. These are both part of the same database, although we have multiple tables here that we're working with. So say in the case of employee table, we want like IDs always, name, age, and wage, just some random data to collect, but also notice that the ID columns for the two, they have the same IDs to start with because IDs are only unique within the same table, and they don't have to be unique within the entire database. Is any questions so far about like table construction, IDs, type enforcement?
Deleted ID is kind of occupying the memory, or it's like completely deleted from the memory?
It's gone forever. Yeah. Well, unless you have a backup, but yeah. Cool. All right, moving forward, we're talking about using databases and tables versus storing things as a JSON or other dictionary-like format that we were doing before. So the key distinction, databases are great. They're better. All data is structured, so like I mentioned earlier, we get a bunch of type enforcement, which is really nice. It also scales much better than a dictionary. I won't go into the nitty-gritty, like why exactly like the data is better, but it's just cleaner, and you have the column and rows is a lot like more data efficient when you get like really, really big stuff, especially for accessing things. So querying data, that's like when you're asking the database questions. So things like, hey, like how many items in this table do I have? It's much easier to do that with a database than you would with a big dictionary. So an example of this, say, is like if you want to query like, hey, from our fruits table, what fruits are in stock? So if we were to do this with a dictionary like we had before or JSON, you have to open it, you have to loop through all the data, and then you just like go through and hey, if like the quantity is not 0, then throw it into like this list we have, and then boom, you're printing the fruits that are in stock. While with the database and tables, we can do something really cool with just one line. And it looks a lot cleaner. So this syntax is, break it down for you, it's like selecting, hey, get me all of the names from our table of fruits where the quantity is greater than 0. And it's much cleaner, it's very succinct, and this is called a structured query language, also known as SQL, if you've ever heard of that buzzword before. But this is what pretty much all databases run off of, and SQL is basically how we communicate with the actual database and the tables within there. It's what executes, retrieves, updates, and destroys all of the data that we're messing with. and it's our main interface for working with tables. So to go into some syntax about how we use SQL and how we build some tables, because you'll need to do that for this week's assignment, we'll go in right now. All right, so the syntax for creating a table in SQL, also preface, all SQL syntax, like the keywords, are done in all caps, so I'm not just trying to like highlight it, it's actually like done in all caps, so yeah, so creating a table, you just say create table, name it whatever, and then everything after is defining all the columns, along with your data types. So an example of this would be, like say we want to create a table of users, so I would have like the ID, I want it to be an integer, I want it to be a primary key, and auto increment. So integer, I'm just defining the type. Primary key indicates to the database that this is something I want to be unique across the table. This is what gives us the actual like unique identifier nature of an ID. And I can tell it's also auto incremented. So it knows when it's creating new rows for this table to auto increment ID for me. Next field we can go through is like name. It's a type text, and I want it to be not null. So not null enforces that any data that I'm trying to add to this table, it has to have a non-null text field. And you can see the same with age as well. So this is a way of enforcing that, hey, people aren't putting ill-structured data in our table, and we can preserve some consistency across our data set. And then finally, emails, character field, another just random example. 50 indicates like the max length of the character string that we're going to be working with. So we've created a table. The next thing you want to do is be able to add stuff into the table. So creating data follows this general format. So you want to insert into a particular table. And then the next thing is where you define all of the columns. So you say column 1 all the way through n. And then you would actually give the values of each column as you go along. So an example of this, actually before the example, the columns part, you can actually omit it in the SQL syntax if you're inserting all values. So in the case of that you weren't providing values for all columns, you'd still want to write out all the columns, and then in the after the values part, you'd say like value 1, value 2, then say it was like empty. You just put it down null or leave it blank, and then say like value 3 and so on. And so this is just a cleaner way for the table to know, like for SQL to know that, hey, I'm trying to put everything in so you can omit writing all that extra syntax. So an example for us, say we want to use the same users table. We want our columns are name, age, and email. We omit ID because it's auto-incrementing for us, and thus we have no control, or we don't want to have control of manually choosing the ID with each item we add to the database. So the values in this case would be John Smith, he's 21, and this is his net ID. Also, I hope this doesn't belong to someone. That'd be fun.
So is it not case sensitive? Because like the name, age, and email are lowercase here, but they were capital before.
I was saying for the the column names. No, they should not be. No, I was just all capsing stuff. Yeah, I didn't need to all cap stuff. Thank you for catching that. Yeah, actually for the table name, you should. All right, actually go back. Create table users. This is actually not like real. This is kind of just like abstracted. This is actually, you wouldn't like type this in your code. You'd actually want to use like regular data types like users. You'd make it like a string, and then so everything within those parentheses you'd put all like within one massive string, as you'll see in the demo. But like this is not like literally what you would actually type. Yeah. Cool. Any questions about how to create a table with SQL? How to insert stuff, add new rows? It's just a bunch of syntax, but you gotta learn how to do it. But it's really useful too. All right, cool. So retrieving data follows a select. Then you write out a bunch of column names that you care to know about, and then you say from whatever table that you're trying to learn from. So in our case, another quick syntax tip. You can also say select star. Star just indicates that I want to grab all the columns. So if you want everything in the table, you'd say select star from our users table. Yeah, just another quick way if you want to get everything. You don't have to specify all the columns. But if you want to get only one or a couple columns, you have to name them by name. So you can also indicate conditions on the data that you're trying to select. So we would just add a where condition after the from table name. So the where condition would be like, I want to select these columns from our users table where, I don't know, maybe let's see this example. I want to select all the adults. So get me all the information from our users where the user's age is greater than or equal to 18. So you can also, side note, you can also chain conditionals in here. So you can say like where age is 18 and name is John if you wanted to. You can have more than one condition within the where statement. You wouldn't want to say like where condition 1, where condition 2. You do it all within just like ands and ors, chaining it after one where. Cool. So next one is updating data. So you update from a particular table, and you want to set your column and value pairs. So you'd say column 1, value 1, and then you could also imply a where condition there too. So you can say I only want to update a certain subset of my data. You would specify that in the where condition. So an example here is I want to change John's email. So I want to go into the users table, and I want to set the email field, the email column, to jsmith@gmail.com. And the where ID equals 1, that's just saying like the ID of John I know is 1, so I only want to update his email, so I will do that with this condition. Cool. Last thing we want to be able to do, so create, retrieve, update. Last is destroy, so we just say delete from this table for whatever condition we want. So say I want to delete John now, I just say delete from the users table where our ID is 1, because that's his ID. Any questions about SQL syntax, why we use SQL?
Don't be caught up on kind of like the syntax itself. It's kind of picky, so if you're ever unsure, there's lots and lots of documentation and resources online. If you can just Google like how to do a select, like if you forget it has to have a semicolon at the end, like it'll tell you. Google will tell you everything.
All right, cool. Well, without further ado, we shall get into the demo so you can actually see how we use this when building an application.
All right, so I have some like template code for you guys to have. So all we're going to be doing is just like filling it in. It kind of relies on the fact that if you followed along the demo last time, we have our app.py, but today we're going to be introducing a new file called db.py, which you can imagine is for interacting with our database. So I would recommend you go to our Piazza, and under the resources tab, there should be like demo template, and there should be one called db.py. So if you want to just take a moment to get that up so you can not have to write like a lot of the wacky stuff. And can everyone hear me? Okay, probably. Oh, yeah. Cool, so what we're gonna be using for our database system, so what we just learned was SQL, structured querying language. So as you notice, it's a language, not necessarily like something that will create a database or manage a database. So there are a lot of different ways to manage a database. We call them database management systems. You probably have heard of maybe one or two of them. They include like MySQL and Postgres, and then there's some that don't even use SQL, but we won't really cover those. For the purposes of our class, we're going to be using something called SQL Lite. So let me just pull that really quickly. So SQL Lite is, as you can imagine, a very, very lightweight database management system. And the reason why we're using it is that it's really good for kind of keeping self-contained data on like a local device. That means it won't scale up to like gigantic proportions, but for the purposes of just learning how to manipulate databases and work with them, SQLite will work very well. And to download it, there's like a getting started. Really, there's just a download section right here. And depending on if you use Windows or Mac, you can pick one of these distributions to download. We'll put a Piazza kind of specifying, because this is a little bit confusing. There's a lot of them. So right now, I would recommend like don't download it quite yet. Just follow along the code. And if you ever need to refer back to anything, we will be posting the YouTube video online. So let's get started. I hope everyone has the code. Okay, so let's take a look at our app.py from last time. This is what we had before with our tasks. So we're going to be continuing our task to-do list kind of example here. And like what Connor said, our way of storing tasks is really janky. So we want to be able to, instead of using this weirdo dictionary, we want to use a database. Cool, so let me just make this bigger. If you open up your db.py, this is what it kind of looks like. So this part right here, you don't need to worry about. It just ensures that we only have like one instance of this like database driver running at a time so that you don't get like weird conflicts. If you want to learn more, you can click on this link, but otherwise it's not really important. So yeah, let's quickly go over what we have in our template. So this class is DB, and basically it's just acting as our driver, which means how we're connecting to our database. And all the functions we have here will deal with writing and reading entities from the database. So you can see here we have like initialization, and I'll explain that in a second, but we also have a few functions that might look a little familiar. You'll see our get all tasks, you'll have like an insert task and get task by ID. So you'll notice that those are all functions that we had to define when we did our routes. So they're going to be a little bit different from the functions for our routes because we are going to want to call them in front of inside of our routes. So wherever we do something like, say, so when we're doing this, like create this task and then like add it to our task dictionary and then like increment the counter, all of that stuff can be abstracted out to a different function, which will instead involve our database. So let's talk a little bit about the initialization here. Very quick, we have something called self.con. Con is just kind of a shorthand for connection. And this is like, if you imagine you're opening up like an Excel sheet, like this is the process of just opening it. Like you're opening your connection to the database. And we can do that with, there's like a SQLite 3, which is a wrapper for SQLite in Python that you can import. So here we are connecting to a database called todo.db. So the nice thing about SQLite is that databases are actually stored like as files, kind of self-contained. So like if you have a todo.db and it has data in it, you can actually go ahead and send the file to someone, like, I don't know, give it to them over Messenger or something if you want to cheat. And they can open it up and select the exact same data as what you would have. And you can't do that with Python dictionary. I mean, it only like is there when you run the server. So that's really useful for our purposes. Check same thread is just, are we allowing to make like multiple connections? We don't really need to worry about that. But yeah, so here we're creating a connection to our todo.db. If it doesn't find a todo.db in our like folder, it will actually create it for us, which is really helpful. So what else do we need to do? In our initialization, we also want to initialize like any tables that we might want. So here, eventually we're going to define our create task table. But when we do, we're going to want to call it in our initialization. So whenever this DB driver is initialized, it's going to create the tables we want. And if the tables already exist, then it's actually not going to do anything. So we can go ahead and do something like self.create task table. So we're going to call that later on. All right. So now we're going to want to fill out our create task table. What this is going to do is replace our function when we do create task, all this stuff over here, it's going to do for us. So the first thing we're going to want to do is create our task table. We can't really update any information in the table if the table does not exist. So we're going to want to try to do this. And to do that, we can use our connection to the database, and we use a function called execute. And what this does is that, it says so right here, it executes a SQL statement. So this allows you to run SQL commands inside of Python, which is exactly what we want. So let me just type that up. This triple quotations, for those of you who might not know, is just a way to do multi-line strings in Python. So that's nice just for formatting. So we can actually go ahead and type our SQL here, table, task, and then we want our parentheses. We want an ID in our table with integer and primary key. I believe by default it actually has auto increment if you designate it as a primary key. And then we can have our description, which is going to be text, and we don't want it to be empty. We want you to require that we have a text. And then we want our done, which is, if you remember, whether or not you finished your task. And then every SQL query needs to end in a semicolon, so we'll put that there. So whatever goes inside of the string that you pass to execute is literally like a SQL command. So it's not Python, it's SQL. So we're putting this in a try, except just in case something goes wrong, we can print out our exception, and this is just kind of like a sanity check. Cool. So that means whenever we initialize this, and we will be initializing it in app.py, we will go ahead, oh, hello. Oh, this doesn't need that. Yeah, well, it will go ahead and create this table. So once we have this table, imagine that our table is created, and we would want to get all of our tasks. So how do we do this using SQLite? So to get our tasks, we want to imagine that if you think of a table, it's kind of like a 2D list, a 2D array, where you have your rows and columns. So there are a few functions to allow us to retrieve the data in the form of, say, like a 2D matrix, which is a table. We can do something called, we can use a cursor, and if you think back to like the Excel analogy, like you can take something and select it. So you can think of our cursor as like a way to select information, and we can do another SQL command. So we want to execute another statement. And what we can do is just do select all columns from task. So from our table task that we created here, we're going to select everything. And what this is going to return is this is going to return a 2D list. Well, it's very similar to a 2D list. It's actually a SQLite cursor object, but you can think of its data as a 2D list. So because it's similar to a 2D list, we can actually just iterate for each row in this cursor. And remember, each row is like a collection of, one instance of like the fields. So it would have something like ID description done, and we can collect our information. To do that, we're going to want to have something that we're going to return later on. So we'll have just a variable to collect everything we want to return, because remember, in the end, we want to return something like a list of our Python dictionaries that represent each task. So for each row, for each task, we can just append it to our tasks list. So because our cursor is like a list, the list, what it's going to look like, instead of saying like ID and then its value, and then description, and then its value, it's just going to say like the value of each thing without its like label. So it would look something like this if you were to write it out, like 0, something, and then like false. And we don't want that. We want to make sure we have something like ID, right? We want to know what it is. So we can just parse that information out by creating a new dictionary with the information we get in the row. So the ID is going to be row 0, and this is kind of arbitrary because it's just whatever order you create your columns in is going to be the order that your like values are going to be in this list. So because ID is first, it's going to be row 0, and then we'll have description. That's going to be row 1, and then our done, which is going to be row 2. Cool, so now our task is going to have all of these dictionaries, and then we can just return tasks, and that is very helpful. So we can't really return tasks. I mean, it won't be interesting if we don't have any tasks to return, so we want to make sure we know how to insert a new task into our database. So this function should take in a description and whether or not it's done, just so we know how to, like, what we're going to be inserting in the database. Again, we're going to create a cursor. So let me just erase this. Cursor. And this is going to be a little bit different. So this is called self.connection. You can guess it, cursor. Why is this different from the cursor we have before? This part right here, where we have self.con.execute, is actually kind of a shortcut for creating a cursor. What this actually does is that this will create a temporary cursor and then go ahead and execute this SQL and then return that cursor. While here, we're actually formally creating the cursor, and then we would manually do something like cursor.execute. So if we were to like write this line out kind of without the shortcut, we would have like self.con.cursor, and we would have like some cur equals that, and then we would do cur.execute, and then SQL. But why would we do that when we can just write in one line? So, but we are going to do it here because there's going to be a little more that's going to be involved with our SQL query. So here we're going to want to execute again, cursor.execute. And what is our SQL statement going to look like? Like Connor said before, we're going to be inserting information. So we're going to do insert into our table task. And then we have our columns, description, done. And then we want to insert values. So how do we insert our values here? Because we're passing our values in as a parameter in our function here, description and done. And you can't really just type in like description inside of the string. How SQLite in Python actually handles this is that you can put these placeholder variables here. So they're represented as question marks. If you've ever used like formatting strings where you have like that, it's very similar. So when you put a question mark where you want to represent this as a placeholder for some variable that we're going to be passing in, and then as a second argument to execute, we can put our parameters. And that's where we can put our description done that we pass in through our function parameters here. And it's pretty important that you make this a tuple. So a Python tuple is when you have like the parentheses and then separated by a comma, just because this only accepts in a tuple. So what end up being executed is like insert into task, description, done, values, and then the value of the description, which might be like do laundry, and then the value of done, which might be like false. So once you execute it, what you need to do is you need to commit your change. So this is like if you type something into your Excel spreadsheet, but you don't actually save it, then like if you exit out, nothing is saved to your spreadsheet. This is like the same logic. You need to commit your change to the database so it's persisted there. And this only needs to be done if you're like updating or inserting or deleting, or I don't even think deleting, like these changes that you make to the database, you need to commit them. But if you're just doing something like getting information, you don't need to save it. You're just looking at it. Cool, so now that that's saved in the database, what do we want to return? So we will probably want to just return like the ID of the task we created. We just want to make sure like, hey, this was successfully created. This is the ID of the task we just made. And you can do that here by doing something pretty simple. You can return the cursor dot and then what we call last row ID. So this is a field in the cursor and it's pretty self-explanatory. Whatever last row that we just inserted into the table, get the ID of that, and that's what this is. So because the last thing we inserted is, the task we just inserted, this will return that ID. Finally, we will have our get task by ID. And this can be done similarly to what we did before by first creating a cursor, and we'll use our shortcut method by just executing from the connection instead of like a instance of a cursor. And we will do something like select all rows, or rather all columns from our table task where, and this is where we have our condition, we want the ID to be something. And what is this something going to be? It's going to be the ID that we pass in the parameter here. So, oops, not DI. So here we're going to have a tuple. You probably know tuples to be more than like one value. Like you usually have a tuple as like 2 or 3 values, but because this function takes in a tuple, we have to do something kind of janky and create the tuple with just one item in it. And make sure you have this comma here. Python will not recognize this as a tuple if you don't have a comma. So now please make sure to do that, because we have struggled with this many times. I've done this a lot where I forget the comma and I have no idea why I'm getting an error. That's why. So now we have a cursor, and what is this going to select? I mean, since we're only getting, if your data, yes?
Do you need semicolons after your SQL command?
Oh, I do. Thank you. It will continue running if you don't have semicolons, so that would be bad. Cool. So we know that this cursor should only have one row in it because you're only getting something by its ID, and there should only be one thing in your table with that ID. So what we can do is, for row in cursor, and there's only going to be one row, we can go ahead and return this new object, ID, and then row 0, our description, row 1, and then our done, which is row 2. And this should make sense because we're only getting one task. But what if we don't actually find anything with that ID? Like, what if you deleted something with ID 3 and then you're trying to find it again? What do we do? So because cursor's data looks kind of like a 2D list, if it doesn't actually find anything, what cursor will end up doing or becoming after we execute the SQL command is that it's just going to be an empty list. So when we try to iterate through each row in the cursor, there's not going to be any rows. So it will actually just go ahead and skip this whole iteration part. So it'll go straight to, we want to return, none. There's not going to be anything in here. So this is kind of like the basics of how you would use your connections and your cursors for SQLite. But how do we actually call these functions from our server? We can go back to app.py here, and what we can do is we can import our DB. So this is just going to be this module right here. And it's called DB because the file name is DB. And we can create an instance of our new DB class. So we don't need this anymore. We don't need tasks or ID counter because that's all handled by the database. So instead, what we can do is create a new object DB, which is just our DB instantiation. So how do we use our newfound DB? Oh yeah, so this part here, the like little lowercase db, that's from our imported db package module from over here. So you just want to call our db files and then our db class. So we see here data, we can't actually use tasks anymore because tasks doesn't exist, which is a good thing. Instead, what we can do is we can take our db driver and just call the function we make, get, this is all, get all tasks, and then here. So because we know get all tasks will return the exact same thing as what this line did before, which is like the list of dictionaries, we can be assured that our data is safely gotten. Same thing for our create task. So now we don't need something like, oh, we don't have task ID counter anymore. How are you going to get our task ID? remember that when we have our insert task, we actually we create our new task, we insert it into the database, and then we return the ID. So instead, and we don't need this task ID counter anymore, we can just do our db dot, and then what is this? Insert task. So the tasks dictionary here and our task counter we don't need anymore. But we'll go ahead and just continue creating this task, so when we return our data as a response, we're good to go. Oh, right. So our insert task actually takes a description and done, so we'll just go ahead and pass those in from our description here that we parsed before from the request body. So we'll have description. And then what do we want to pass in for done? Well, remember that our default here is just false because you don't want to be done with your assignment or your task before you actually create it. So we can just pass that in, and that's good to go. And then finally, in our get task, we see that, oh no, like we don't have tasks anymore. How are we going to get a task? Instead, what we can do is this. So let's just erase this for now. We can get some sort of task from our driver, get, and what is this? Get task by ID. And then we notice that we either have an actual test or task, which is a dictionary here, or we have nothing. So we want to do different things depending on what our response is. We can do if task is not none, so meaning we actually found it and it's a dictionary, we can go ahead and return our success. And then, oh, my bad. We have our task ID here. So, right, so we want to successfully return the task. And if your task is none, then it will go ahead and bypass this if statement and return our error. So this is really all you need to do. Look how much cleaner our code looks in our routing. Like it's a lot less jumbled because all of the heavy lifting of updating our data is all done in our db.py. So our expected result should be that when we run our app.py, so it says table task already exists. That's totally fine. If we run a postman request and we get our tasks, we see that, oh, because we initialized our database with no information and all we did was get the tasks. We didn't create any tasks. Our data is nothing. We have an empty list. And if we want to create a task, we can look at our body, and this is what we're sending over. We can create the task. Oh, look. It says that we have successfully created everything. It has all the information we need. And if we go back to get tasks, we can see that it is here. Let's try again, and let's do another task, like laundry. Let's send that over. And you see the ID is auto-incrementing. We didn't have to do anything with the ID, but because we designated as a primary key, SQLite knows that it should probably be a different ID. We get all tasks again, and we see that these are all here. Just to finish off, let's just get a task by ID. So task's not here. It's probably this. 1, oh right. There's no ID 0 here, just task 1. And we successfully got everything. You might remember from the last demo that these responses look exactly the same even though we changed a lot of stuff in our server. And that's exactly what we want as a backend. If we rearrange our internals, our client should be able to access the exact same information without worrying about, like, if we change something, then should they change something? And we should only, actually change something that affects them if they need it. So this is kind of the demo on how to use SQLite. This video will be posted on YouTube if you didn't quite catch all of that. Does anyone have any questions? Sorry, we are keeping you a little late today. Cool. So we'll have an assignment. Oh, do you want to talk about that?
Just as you're packing up, a note about our second assignment. We'll be trying to recreate Venmo, and this assignment will actually be we'll give you for like we'll be working on this Venmo project for 2 weeks actually. So this first week is all about setting up your database, your db.py file, and creating a users table. The API spec is on Dropbox paper for you. We'll release the handout later tonight, and then next week we'll be using still SQLite, and we'll be adding more functionality to our Venmo application. So, thank you.
Miss 温老师，我能为那 shoulder down 是因为我的